Okay, so we have OP labeled as R. Okay, if we were to measure this, okay, you guys don't have rulers on you, but if you did, you would measure from here to here, and it's given by 3 centimeters, okay? So if you were to estimate, would you agree? About 3 centimeters?
Yeah.
Okay, determine the circumference of the circle. Okay, give the answer as an exact value in terms of pi. Do you guys remember the circumference formula?
Is it pi r squared?
No?
2 pi.
2 pi r. Good. Pi r squared?
No, yeah. I said something differently.
Oh, okay, sorry.
Yeah.
Okay, so the circumference of a circle is 2 pi r. Okay, now if we know our radius, we could sub that in and actually calculate it, but we're not going to worry about that for this example. Okay, what we're going to do is cut the piece of string or thread equal in length to the radius of the circle. So if we had a piece of string, we would cut it the exact same measurement as the radius. And then what we're going to do is we're going to place that piece of string on the outside of the circle. Okay, and when we place the same length, 3 centimeters on the outside of the circle, we go to about here, and I want you guys to mark that point as Q. And then we're going to join O to Q. And what do you think we could call this? From the center of a circle to the outside, what's it called?
R.
Good, it's our radius. Okay, so it's also going to be 3 centimeters long. How long was our arc? How long was that piece of string? 3 centimeters. So it's also the length of our radius. Okay, and if we were to state the length of OQ, because it's the same as our radius, we would put 3 centimeters. And also the length of our arc, PQ, would be 3 centimeters. So if you were to take this piece of string and you were to put it around the circle, how many times do you think you could place it around the circle? How many pieces of string? 6?
5.5.
5.5?
Okay.
6 and a chunk.
I say 6.
It's just an estimate. So if that piece of string is 3 centimeters long, then let's just use the 6 as an estimate, then the circumference would be about 8 centimeters. Okay, approximately 18 centimeters. So moving on to the radian measure of an angle. So in the diagram above, the measure of the angle POQ is defined to be 1 radian. So if we go back up here, in this exploration we haven't really described what a radian is yet, but they're telling us down here that the angle POQ is 1 radian. So this right here, that's basically equal to 1 radian. Okay, the angle that measures the arc length with the exact same length as the radius is 1 radian. You know, I'll get into a little more detail down below. So in general, we have for a radian, it's the ratio comparing the length of the arc to the radius. And as a formula, or an equation, we would have the measure of the angle in radians is equal to the length of the arc forming that angle and the length of the radius, or in short, arc length over radius. So I'm just going to use this example because it's what we had above. Okay, we had the radius was equal to the arc length. So if I were to sub that into that formula, let's take a look here. Arc length was r, or 3 centimeters. Radius is r, so what do we end up with? 1. Which means we have 1 radian. So this angle here is 1 radian, or 1 rad. 1 rad angle. Just trying to wake you guys up a little. Okay, so here this angle, POQ, is considered 1 radian. If you guys had to compare this example to diagram 1 here, I'm just going to draw an imaginary line. How many radians do you suspect? 2 radians. Yeah, very good. Okay, so, because this is approximately 1 radius, 2 radius long, then we need to figure out what is this angle here. Okay, well if we use the formula, okay, the measure in radians would be equal to the arc length, which is 2r, over the radius, which is 1r, so we get 2 radians, or 2 rad. Okay, so radians are just another way of describing an angle. So, you guys are probably familiar with inches and centimeters and all that, but they're actually 2 different measurement systems. So there's conversions that take place when you go from measurements to measurements. You learned that in grade 10. Similarly, there's a conversion going from degrees to radians. So let's just do a little exploration to figure out what that conversion will be. And if you listened closely in the video at the beginning, you maybe would have caught it, but it was pretty quick, so I don't think you did. We have a circle with the center, the radius is our units, and if you guys had to describe in degrees, what would be a full rotation? 360, good. Okay, so 1 complete rotation in degrees is 360 degrees. Now in terms of arc length, going all the way around, what would we describe in terms of pi? What is the term called when we go all the way around a circle? Circumference. And what was the formula for circumference? 2 pi r, good. So the arc length of 1 complete rotation is 2 pi r, okay, and that's the circumference of the circle. So just keep in mind that with radians, we're not going to be using degrees, we're going to be describing it by arc length. So although it is 360 degrees in terms of arc length, we would say 2 pi r. So for the ratio arc length over radius, our arc length was 2 pi r. And if I divide by the radius, what's going to happen to those r's? Cancel out. So what would be the angle that describes going around 1 full circle? 2 pi. Okay, so when we're talking about radians, we would have 2 pi radians as a full rotation. Okay, and 360 degrees would be equivalent to 2 pi rad. Okay, so if you're ever talking about 360 degrees around a circle, okay, 360 degrees is equivalent to 2 pi radians. That is the angle. So if 360 degrees is a full rotation, what would a half rotation be? You guys are smart. 180 degrees. Okay, and the arc length, if a full rotation was 2 pi r, what's half of that? Pi r. Good. So if we're trying to figure out the radian, we would have to divide the arc length divided by radius. So the arc length for half of a circle is pi r, and the radius is still r. We divide those, we end up with pi. So in conclusion, we can state that 180 degrees is equivalent to pi radians. So on this side of the circle, if I've gone from 0 to 180 degrees, I could also describe that as pi radians. So now that we have some basics down, we can derive the formula or what we would multiply by to go from degrees to radians or radians to degrees. So we all agree from this statement that pi radians is equal to 180 degrees, yeah? If I just wanted 1 radian, what would I have to do with that pi?
180
I would have to divide both sides by pi. So here the pi's would cancel out, and here I would just divide by pi. So 1 radian is equal to 180 degrees divided by pi. In other words, to convert from radians to degrees, we need to multiply by 180 divided by pi. Conversely, if we want to go from degrees to radians, we know that 180 degrees is equal to pi radians. So if I just want degrees, that means I have to divide by 180 degrees. That cancels out. Whatever you do to one side, we do to the other. And you end up with 1 degree is equal to pi over 180. Okay, and to convert from degrees to radians, we would multiply by pi over 180. We're dividing by the degrees, we don't want them. Okay, similarly here, if we're converting 2 degrees, we're dividing by the rad, by the pi. So a very important note, the degree symbol is only used if we're talking about degree angles. So anytime you're listing a measurement in degrees, you have to have this symbol. Okay? If you are talking about 30 degrees, you would have to put 30 degrees. But if you're talking about 30 radians, you would leave it as 30, or you would say 30 rad. Or you could say 30 radians if you wanted to write it out fully. Okay, all of these 3 things are the same. 30 degrees or 30 degrees in writing would be the same. This is just a really important thing. If you ever have 30 on its own, I will assume that you're saying 30 radians. Okay, mathematically that's what it's saying. If you put a degree symbol, then I'll know what you're talking about though. Or if you write the word degrees. Okay, so just be very clear if you're talking about radians or degrees, because that could be a really different angle. So just a little summary how to convert between degrees and radians. It's important to note that pi radians is equal to 180 degrees, and also we noted that 2 pi equals how many degrees? 2 pi radians equals how many degrees? 360, it's a full circle. 360 degrees, gotta put the degree symbol. If we are converting from degrees to radians, we multiply by pi over 180. And if we're going from radians to degrees, we multiply by 180 over pi. So let's put that into practice. For example number 1, we need to convert from degrees to radians. So if that's the case, what do I have to multiply my radian by? Or sorry, my degrees by? Okay, I'm going from degrees to radians. So I multiply by pi over 180 degrees. Okay, you want to get rid of the degrees, keep the pi. So let's multiply this by pi over 180. And I'll just need a little help. What is the ratio of 270 divided by 180? We want to keep our answer in terms of pi. 3 over 2? So reduce the fraction 270 over 180. You should get 3 over 2 pi. Now, for part B, they're asking you to calculate to the nearest tenth. So what would you have to put in your calculator for this? Say if I didn't want the answer in terms of pi, I just wanted what is the decimal, so the nearest tenth. Yeah, you could go 270 times the pi symbol divided by 180. You guys know where the pi symbol is? Okay, so second, and then I have to check again. Second rooftop. A little upward arrow. Okay, second rooftop, and then your pi symbol's there. Okay, but they wanted it in terms of pi, so let's try 315. Again, we're going to multiply by pi over 180 degrees. What is the ratio of 315 divided by 180? 7 over 4, thank you. So we have 7 pi over 4. Okay, the second example is asking us to convert again from degrees to radians, but this time to the nearest tenth. So we're still multiplying by pi over 180, that's for both questions. But this time we calculate it fully. So 70 degrees multiplied by pi over 180. To the nearest tenth, what do you guys get? 1.2. 1.2?
Yeah.
So I'd say 1.2 rad. If possible, whenever you're talking about radians, just write rad or radian. Okay, that way it's really clear what measurement you're talking about. Okay, 205, if we multiply by pi over 180, what do we get?
3.6.
Thank you. For the next two sets of questions, we need to go from radians to degrees. So for these examples, we have to multiply by 180 degrees over pi. So if we have pi over 4, we're going to multiply that by 180 degrees over pi. What's going to happen to those pi's? Cancel out. Okay, and then if we calculate 180 divided by 4, we should get 45 degrees. Okay, next one, going from radians to degrees. So we multiply by 180 degrees divided by pi. Pi's cancel out. And all we have to calculate now is negative 7/3 times 180. So in degrees, what do you get? Hopefully it's negative.
Negative 420.
Yeah. Negative 420 degrees. Alright, now these next examples, they're describing in radians. They don't have the pi symbol, so you can't really cancel out the pi's. But we're going to take our 1.57 and we're still going to multiply by 180 degrees divided by pi. So your calculation just includes the pi symbol this time. So 1.57, multiply that one by 180, and then divide by pi. What do you guys get there? The near. What do you get?
89.9.
Okay, and when you round to the nearest tenth,
Sorry, 90.
0.0. Okay, just make sure you have to the nearest tenth. You got the right values. Alright. Okay, negative 1.4 radians times 180 degrees over pi. What do we get there?
Negative 80.2.
Negative 80.2. Good. Alright, so that's how you convert from degrees to radians and radians to degrees. So if you're struggling with just looking at the pi symbol and figuring out where that's oriented on your unit circle or just where it lines up, where your terminal arm ends, you can always convert to degrees, and then if it asks for radians as a final answer, you'd have to convert back. Okay, this next example is just refreshing our memories on coterminal angles and reference angles. We briefly talked about it at the beginning of class, but there is a summary to start us off. So coterminal angles are angles that share the same terminal arm. Okay, they're separated by multiples of 360 degrees. So if I did a full rotation, I would be back at that same terminal arm. Or if I went in the other direction, full circle, I'd be back at that same terminal arm. 360 degrees is equivalent to how many radians?
2 pi.
2 pi, perfect. Pass the first test. Okay, now one thing we didn't review, but we did cover in lesson 1 was the concept of a principal angle. So principal angles are the smallest positive angle, and they'll always be between 0 and 360 degrees. Okay, or if we had to create a new domain here, 0 degrees in terms of radians would be 0 radians, and 360 degrees in terms of radians would be 2 pi radians. So just thinking about a circle, we start at 0 degrees or 0 radians. If we were to go, say, up to 90 degrees, maybe I'll just label these first. Okay, so we go 0, 90, 180, 270, 360 degrees. If I were to label that using radians, okay, we know that 180 degrees is pi radians, and we know that 360 degrees is how many? 2 pi. Okay, so if we were to break this up, okay, halfway between 180 and 0 degrees is 90 degrees. So half of pi is just pi divided by 2. Okay, that's in radians. So we're at half, 1, what would go here? How many pies? 3 over 2, we're at 1.5 pies. And then if we go full circle, we have 2 pies. So it's just good to be able to compare where the degree measurements would be and how they would actually look as a radian measure. So knowing how we break this up, we can now talk about reference angles. So the reference angle is an acute angle that's formed between the x-axis and your terminal arm. So for example, if I had an angle that rotated to quadrant 2 to this terminal arm, I would have a reference angle that lies between the terminal arm and this x-axis. Okay, so it's this angle right here. And there is 4 different ways to calculate your reference angle depending on if it was quadrant 1, 2, 3, or 4. Similarly, there's 4 different ways to calculate your rotation angle. So let's just talk about quadrant 1. If you had a reference angle given, what would be your rotation angle? It's exactly the same. So in quadrant 1, your rotation angle and reference angle are exactly the same. This table of values, it's referring to what would the rotation angle equal. So here the rotation angle would be equivalent to the reference angle. So if you rotated 30 degrees, your reference angle is 30 degrees. In quadrant 2, okay, your reference angle would be here. We've got to figure out what would that rotation angle be from 0 to that terminal arm. So your reference point is on the x-axis. That's 180 degrees, right? So if you went 180 degrees and you subtracted that reference angle, you would get the rotation angle. Okay, that's in reference to the degree measurement. How would I write that in radians? So instead of 180, I would use pi. Good. So it's pi minus your reference angle. Okay, in quadrant 3, so if I had a reference angle here, okay, how would I figure out the rotation angle to that terminal arm? What's half a circle worth? 180, good. And 180 plus the reference angle, would that give me my rotation angle? Yeah, so that's what it says here as well. 180 degrees, that's half circle, plus this little reference angle between the x-axis and the terminal arm. That will give you your rotation angle. So the same thing goes in radians, except for instead of 180 degrees, we use pi. So it's pi plus your reference angle. And lastly, if we're in quadrant 4, and your reference, or your terminal arm terminates in quadrant 4, you will have a reference angle here. So how are we going to figure out the rotation angle from 0 to that arm? Well, it's given to you. 360 degrees minus your reference angle. So in terms of radians, we would have 2 pi. Okay, 2 pi radians minus your reference angle. So in example 5, we're just going to practice using that table. So in each example, we need to draw the angle in standard position. Okay, so that means we need a positive angle between 0 and 360. Then we need to state the principal angle. Okay, and determine one positive and one negative coterminal angle, and then represent the general rule. Okay, so pi is equal to our angle is equal to 3 pi over 4. So let's just label this out again. We have 0, pi over 2, pi, 3 pi over 2, and back at 2 pi. So 1 full pi is 180 degrees. 3/4 of a pi, it's not quite a full pi, right? So we're going to terminate somewhere here. We need to figure out a coterminal angle to this angle here. Okay, this rotation angle is 3 pi over 4. So for part 1, we've done that. Part 2, stating the principal angle. Do we have an angle between 0 and 360 degrees? Or in terms of radians, do we have an angle between 0 and 2 pi? Yeah, okay, we've got that already. So our principal angle will be 3/4 of pi. For part 3, we need to find one positive and one negative coterminal angle. So coterminal angles share the same terminal arm, and the way we get them is just by rotations. Okay, they need to be full rotations, not part rotations. You can go in the negative direction or the positive direction. So we could go 3 pi over 4 plus a rotation, and we just need to figure out the fraction of pi. Okay, so 3/4 plus 2, you can do that in your calculator, or you can just get a common denominator. Okay, we need a common denominator of 4, so multiply in the denominator and in the numerator. We get 3 plus 8 over 4. So it's 11 pi over 4.
What did you multiply by 2?
Pardon? So what I did is I had 3/4,
Yeah, and then it's,
and you had to add 2.
yeah, what would it be? 4, like when you multiply 2 by,
4?
yeah,
Yeah, so I needed a denominator of 4.
yeah.
And if I multiply in the denominator, I also do in the numerator. So then
Okay, yeah.
3 plus 8
Yeah,
gives me 11 with a denominator of 4. But we were talking about how many pi's we have, so you have to make sure your answer is pi. You're okay there, Booker?
yeah.
Yeah? So this would be a positive coterminal angle, 11 pi over 4. And that's just taking this angle and rotating it one more time around. Okay, what about a negative one? Instead of adding 2 pi, we'll subtract 2 pi. So this time we have 3/4 minus 2. We need a common denominator, so multiply by 4, multiply by 4. 3 minus 8 gives me negative 5 pi over 4. And if you don't want to spend a lot of time doing this, you should be able to do it in your head, but if not, just go 3/4 minus 2, math frac, enter, and you have your fraction, negative 5/4. Don't forget the pi though. Okay, so positive coterminal angle, negative coterminal angle, and lastly we need the general rule. Okay, so what we're going to do is take our principal angle, 3/4 of pi, and we're going to add rotations n times. So this will be our general rule. For finding any coterminal angle, you would have to use this calculation. Now, one thing that's important is n is always going to be an integer. You can't rotate by like 1.5 turns. It has to be 1 turn, 2 turns, 3 turns. Okay? You can't have just partial rotations. They've got to be full rotations. Okay, that can go in the positive direction, or as we can see, the negative direction. So I'll just make a little note that n has to be an integer. Alright, for part B, let's label our axes, but we're going to go a little bit different because we have a negative angle. Okay, so we're going to go the opposite direction. So this would be 0 radians. We'd have negative pi over 2 radians, negative pi, negative 3 pi over 2, and negative 2 pi. So negative angles always go clockwise. So 1/3, that's smaller than a half, so that will be roughly here. Okay, our rotation angle will go all the way through. Okay, so our rotation angle was negative pi over 3. We need to figure out which angle will be coterminal. So we drew our angle. Now we need to state the principal angle. Okay, principal angles fall between 0 and 2 pi. Is our rotation angle between 0 and 2 pi? No, it's negative. We need something positive. So basically we have to find a coterminal angle that's positive. So we're going to go negative pi over 3 plus 2 pi. And our principal angle will give us, we have negative 1 plus 6, so 5 pi over 3. Okay, negative 1/3 plus 2, you should get 5 pi over 3. I did my math right. And for part 3, we need a positive coterminal angle and a negative one. Now if we were lazy, I could just say, well, we already found a positive coterminal angle right there. So we could say we're done, but we're practicing, so let's find one more. Okay, using the principal angle, 5 pi over 3 plus another rotation puts us at 5 plus 6 is 11 pi over 3. So you're just multiplying that denominator up. So 3 times 2 is 6. 6 plus 5 is 11 by your common denominator. That's our positive one. Now I need to figure out a negative coterminal angle. Now, if I were to take 5 pi over 3 and I'd go back a rotation, I'd just be back at negative pi over 3, right? Let's find a new one. So 5 pi over 3 minus 2 pi times how many rotations? Maybe we could just do 2 or 3. Doesn't really matter, as long as it's more than what we had before. Okay, so I have 5 over 3 minus 4. So if I multiply by a common denominator, I get 5 minus 12, so that's negative 7 pi over 3. And that's a negative coterminal angle. I think, Bernie, you said 3. You could do a 3 if you wanted. As long as it gives a negative angle. Okay, and in this case, just being, they didn't give us any domain that we had to stay in between, so that would be totally fine. You can pick whatever coterminal angle you want. Okay, last one, the general rule would be the principal angle, which was 5 pi over 3, plus n number of rotations. Okay, where n has to be an integer. So 5 pi over 3 plus 2 pi times n. erase this one? Emma, are you done here?
Oh,
Yeah, okay. No, I just didn't want to erase it if you're still doing it. Okay, next example is finding the reference angle. So I know the table of values was talking all about rotation angle, but it's pretty much the same calculations. Okay, so they're giving us the rotation angles. We need to find the reference angles. So best thing to do is draw a picture to start. Okay, 0, pi over 2, pi, 3 over 2 pi, and 2 pi. Okay, just while we're getting used to this, it's always good to just label your axes, then you know what quadrant you're going to fall into. So 4/3, that's something bigger than 1, but smaller than 1.5, right? Okay, so in that case, we're going to be between 1 and 1.5 pi. So our rotation angle will terminate in quadrant 3. Our goal is to find the angle that lies between that terminal arm and the x-axis. We're trying to find this angle right here. What is that?
That minus pi.
Absolutely. So we want to go our rotation angle minus pi in this case. Okay, so 4 pi over 3 minus pi, that gives me pi over 3. Okay, next one, negative 5 pi over 4. So we have to draw in the negative direction this time. 0, negative pi over 2, negative pi, negative 3 over 2 pi, and negative 2 pi. Now if you're unsure, let's just calculate. What is negative 5 over 4? Is that 1.2? Yeah? Yeah. Okay, close. 1.25. So we're here and just a bit past. So our terminal arm would go about there. Actually, I guess it'd go halfway. Want to be a little more accurate? Okay, and we're going from 0 to that terminal arm. So our reference angle, just one more time, is the angle between the x-axis and the terminal arm. So this time we're calculating here. One thing to note is reference angles must always be positive. Okay, so you might do a calculation without finding the principal angle and get a negative, but just note reference angles are always positive. It's a positive acute measure. Okay, so a shortcut for this one would be just going negative 5 pi over 4, and I'm going to subtract negative pi, so I get negative 5 plus 4 pi, so negative pi over 4. But can my reference angle be negative? No, so just make sure that you only select the positive. So in this case, just to clarify a little bit, I did my rotation angle, and I subtracted the reference on the x-axis. So reference angles always have to be positive. So the only other way I could have done this is to find what is my principal angle first. So figured out what is that measure. And then from there, gone 180 minus that measure. But I was just being lazy. Do you want to do the other way too? Okay, so just to be clear, reference angles, so these little angles that fall between the x-axis
Junior class change.
and the terminal arm, they're always going to be positive measures. So even though we got a negative outcome, it's still only pi over 4. Kind of like when you think about distance as a measurement, like typically you would say, oh, I'm 4 meters away from you. I'm not negative 4 because I walked backwards. Okay, so it's kind of the same reference with reference angles. You would use distance as a positive measure, reference angles are a positive measure. The last one. I'm just going to help you guys out with it, but I'm going to let you guys try it on your own. I just want to talk about one thing. So in terms of pi, right, like, so how to get to that 180 degrees, okay, 6 over 6 would be 1 pi, right? Okay, 12 over 6 pi would be 2 pi. Okay, what would be 3 pi? 18 over 6 would be 3 pi, and 24 over 6 pi would be 4 pi. So what's that saying? We have 1 full rotation, 1.5 rotations, almost 2 full rotations. Okay, so because we're at 23 pi over 6. So we're not quite at 2 full rotations, we're almost there. So I just want you to think about that when you're drawing your angle. Okay, you're almost at 2 full rotations, which means what quadrant will you fall in? 4. Very good. So I'm just going to give you guys a moment to try and calculate your reference angle. Did anyone finish yet? What did you get, Chris? Pi over 6? Good. How did you calculate it?
I did 24 pi over 6 minus 23 pi over 6.
Awesome. So you did 2 full rotations, which would put you at the x-axis.
Yeah.
Okay, and then you subtracted the rotation angle. Perfect. Okay, so pretty much Chris went 2 rotations minus the given rotation angle, and he got pi over 6. Did anyone calculate it differently? There is another way. Yeah? How'd you do it?
Well, I converted it into degrees first.
Okay.
And then 30 divided by 180 to get because so I got 690 as the total degrees.
Okay. So 690 degrees, yeah. And then what did you do?
So I divided that by 180 to get the amount of pi that I wanted.
Okay.
So I got 3.83. So that math factor was just 2.06. And then so the angle is 30 for the reference.
Yeah.
And so I did 30 divided by 180 to get that angle. Look at this fraction, which is 1/6, and that's 1/5.
Okay. Yeah, that works too. I just want to go back to this calculation here. So basically what Jared did was he wanted to figure out how many rotations there were. So you figured out there's 3.83 rotations, right? Like, or instead of getting to 4 pi, like you're at 3.83 pi. So you're not quite here, you're right here, 3.83 pi. Okay, and then just go on, tell me one more time after that, what did you do?
Well, so 6, so minus 690, which is 30 degrees, which was the remainder. So I did,
Oh, you did 720, then minus, okay?
yeah.
So if we were to get 2 full rotations, 4 pi is equal to 720 degrees, or 360 times 2. So he did 720 degrees minus 690 degrees, and that gave you 30 degrees, so that's your reference angle in degrees, perfect.
So I divide that by 180.
Good, and then to convert from degrees to radians, he went 30 degrees times pi over 180. 30 divided by 180 is 1/6, so you get pi over 6. Brilliant.
So when you're doing like just the normal method,
Here?
how are you doing like how are you getting?
Pi over 6?
Yeah, like I got it in my calculator, but like I don't
So-
know how to do it. How are you doing it?
So 2 times 2 pi is like 4 pi, right?
No, yeah,
Minus 23 pi over 6.
yeah.
So I need a common denominator, 6, and then I multiply by 6. So then 6 times 4 is 24 pi over 6, minus 23 pi over 6. That gives me 1 pi over
Gotcha.
6. Okay?
Gotcha.
And if you're ever in a bind, just go 4 minus 23 over 6, math frac, and you'll get the 1 over 6 pi.
Oh, and then you just know the one is pi.
Yeah, yeah. So I would almost calculate it without the pi's. I would just go 4 minus 23 over
That
6.
doesn't really work if you use the pi's.
No,
Because it won't
because
matter.
then you'd have to, I think you'd have to divide the pi out later to get
Yeah.
just the fraction.
Yeah.
So you might as well just not even put it in.
Yeah. Okay.
So good job. 2 really good examples on how to solve that type of question. So now that we know a little bit about radians and how to find the coterminal angles, the reference angles, rotation angles, and how to convert from degrees to radians, and vice versa, we're going to look at some examples that apply to real life. So first we need to talk about the formula for arc length. Okay, we just reviewing, the radian measure is equal to the arc length over the radius. And in other words, we have the angle of the arc is equal to the arc length over the radius. Okay, so given that equation that we came from the radian measure, we can create a formula. Arc length is equal to the radius times the radian measure. Okay, so the angle that describes the arc. Okay, so the measure of the angle in radians is theta. A is the length of the arc around the angle. Okay, and R is the length of the radius. So to put this into practice, we have a pendulum that's 30 centimeters long. It swings through an arc of 45 centimeters around the circle, basically. So through what angle does the pendulum swing? Okay, we have to answer in degrees and radians. So first of all, let's just draw a picture. Okay, let's just say this is our starting point, or what is holding that pendulum. Okay, and if the pendulum is 30 centimeters long, and as soon as it's triggered, it starts moving, they're telling us that the arc length is 45 centimeters. Now, as that swings, the radius will still be the same over here. It's still 30 centimeters. Okay, what they'd like to figure out, or what they'd like us to figure out is, what is the angle of this arc length in radians? So we have the formula, and I kind of like it because it just looks like it spells arc. So it's easy to remember. Okay, so the arc length is equal to the radius times the radian measure. We need to solve for this radian measure, so let's just solve for this first. Let's divide both sides by r. And so we get theta is equal to arc length over radius. What was the arc length? 45. Okay, and our radius was 30 centimeters. So 1.5, yep. So we get 1.5 radians. Okay, so that's to the nearest tenth. But if we were to solve this in degrees, how could I go from radians to degrees? What do I have to multiply by? (180 degrees over pi). Okay, so what's 1.5 times 180 divided by pi? To the nearest tenth, you should get 85.9 degrees. Okay, the next one, we have to calculate the arc length to the nearest tenth of a meter of a sector of a circle with diameter 9.2 meters, and the sector angle is 150 degrees. What's your radius? Is it 9.2?
No, you divide it by
Yeah, divide by 2, so 4.6. Okay, and what's your angle? 150 degrees, but we need to, in order to calculate this accurately, we need to convert that into radians. So 150 times pi over 180 degrees, what is that in radians? Okay, if you want, you can just reduce the fraction, like what's 150 divided by 180?
5/6.
Is it 5/6? Okay, so you have 5/6 of pi. Let's just leave that so we don't have to carry all these decimals. We can just put that in our final calculation. Okay, so we have our r, we have our angle. Now we need to find our arc length. Okay, arc length is equal to the radius times the angle. So our radius was 4.6, our angle is 5 pi over 6, and when you calculate that, what do we get? To the nearest tenth of a meter. What do you have, Brett? 12.0? Good. Awesome. So I put a little note here, hopefully you guys caught it. The angle, if you're ever using the arc formula, has to be in radians, okay? This next one's a fun one. See if you guys can figure it out. So we have a circle with center C and a minor arc AB, which measures 15.2 centimeters, as shown. They're telling us that the angle of ABC, this angle here, is equal to angle BAC, this angle here. So these angles are the same. We need to find the length of the radius of the circle to the nearest tenth of a centimeter. Alright, so they're telling us this is pi over 6, and this is pi over 6. We need to figure out what is r. Who would know where to start? So
If you need to find this BC area, I believe.
basically you need to figure out, oh wait, that's how you would start?
Yeah, just
Oh,
put
yeah,
it
good.
down there.
Our end goal is we want to figure out the length of CB or the length of CA. It's the same measurement. Okay, but Chris is on to something. What would you find first?
Like just the angles.
This angle here?
Yeah,
Why?
it's right in here.
Because when we have the formula, arc length equals radius times our radian measure, the radian measure is describing this angle right here. Okay, so let's ignore this little inner triangle here. Let's draw this circle. We have our center point C, our arc length of 15.2. They're telling us we need to solve for r. But in order to solve for r, we need to figure out what is this angle first. So they gave us a little hint. They said that this angle is equal to that angle. What is that angle? What's the sum of the angles in a triangle? 180 or pi. Okay, so step 1, solve for angle C. Okay, or you could have angle BCA. So we know that the sum of the angles in a triangle is 180, so we would go 180, subtract pi over 6, subtract pi over 6. Or pi minus 2 pi over 6, which reduces to pi minus 1/3. 3 minus 1. So do we get 2 pi over 3? Okay, so the angle is 2 pi over 3. So let's just record what we know. We know the arc length is 15.2. We don't know our radius, and we know that in radians the arc angle is 2 pi over 3. So to solve for r, we just simply divide by 2 pi over 3. Emily?
Like the bottom one on that side?
Here?
Yeah.
So, let's erase that for a second. What I did is I combined these first. So, if we have 2 pi's over 6's, I can just go pi minus 2 pi over 6. But 2 over 6 reduces to what fraction? 1 over 3. So I just reduced that. And then getting a common denominator, I have 3 pi over 3 minus 1 pi over 3. So 3 minus 1 is 2 pi over 3. So I just need your guys' help. We've now plugged in the arc angle, which was 2 pi over 3, into the formula. And we also have the arc length, which is 15.2. To solve for r, we need to divide by this 2 pi over 3. So 15.2 divided by 2 pi over 3 to the nearest tenth of a centimeter, what do we get?
7.3.
7.3? Everyone in agreement? I agree. Good job. So radians aren't so bad, hey?
Holy smokes.
I would recommend definitely start with doing number 1 on this, just getting used to what radian measure looks like in comparison to degree measure. And convert.